Today we will be doing the problems of the chapter Fluids in Motion. Okay. Question number 1. Question says the water entering a hose, flows with a speed of 0.10 meter per second through a pipe of 21 millimeter inside diameter, 21 mm inside diameter. What is the speed of water at a point? What is the speed of water at a point where the pipe tapers to a diameter of 7 millimeter. So there are two different cross sections in the pipes given. So we will be using the formula like this: A1 V1 is equal to A2 V2. They have given diameters. I'll change this into radius. Then P pi R1 square V1. Here I get pi R2 square V2. Pi will cancel. So I'll take the radius. What is the radius of the pipe given? Diameter is 21, so radius will be 21 by 2 square. And the speed at this point is given 0.1. R2 is given, new radius is given 7 millimeter. That is, that diameter is 7, so radius will be 7 by 2 square into V2. We have to find what is the speed at this. So these two we can cancel. 7, 3 we can cancel. But there is a square here. 3 square comes 9 into 0.1 equal to V2. Therefore, the value of V2 will come 0.9 meter per second. So this was less diameter, so velocity is more. This was more diameter, that's why the velocity was only 0.1, but now the velocity is 0.9. That is answer. This was the solution of number 1. Question number 2. Question says, what is the speed at which water flows? What is the speed at which water flows from a small hole 3 meter below the water level? 3 meter below the water level in a full tank which is 5 meter high. Okay. Question said the speed at which I can draw a diagram here. There is a tank which is 5 meter high. This entire thing is 5 meter high, and it is filled with water. There is a hole in it 3 meter below the water level. There is a hole 3 meter below, through which the water will come out. The question is asking you, what is the speed with which water flows out? What is that speed we know is called velocity of efflux. What is the formula of velocity of efflux? The formula was root 2gh. Or do we take the value? 2g value suppose is 10. And what is the value of height? The height value is how much? How much should you take as height? The height will be this 3. What is h of here? H is the height of the depth of the hole from the water level. From the water level, where is the hole situated? That height. Don't take 5 meter. Don't take the entire height of the container. Because hole is not situated here, the hole is situated at a depth of 3 meter. 3. The answer will become root 60. Calculate the answer using calculator. Answer will become 7.67 meter per second. This is the answer. Now, this velocity is called velocity of efflux. Okay. They have given some questions in the multiple choice type, and this looks quite important type. So I read the question. can just write a question. Or we'll take this right question. Water flows through a hole. Water flows through a hole. Flows through a hole. Situated 5 meter below water level as shown in the diagram. Find the distance from the bottom of the tank to the point where water hits the ground. Okay. G value, take G is equal to 10 meter per second square. G value is 10, and then given a diagram also here. This is a tank full with water here. Maybe this entire thing is 10 meters, and but hole is situated at what depth of the water level is the question. 5 meter. 5. So from here the water will be flowing out and will be hitting the ground here, this point. You have to find this distance you have to find. How to find the distance? So first we find the velocity with which it is coming on, that is V. We find first V formula we have root 2 GH. H is this is the value of H, small h. The position of the boat from the water level. 2G value is 10 and H value is 5. So 10 times 100, so answer is coming 10 meter per second. This is the velocity with which the water will be coming out. But water will come out like this. Now this is the projectile motion. I think you remember the chapter number 3. When anything is thrown horizontally, how it falls on the ground in the parabolic range like this. And how do we find the value of range? This is range. Okay, this is the value of range. Horizontal range. Range formula, if you remember, it was like this. First we find the time of fall will be how much this height is being fallen. So here we write range is equal to the velocity, speed into time, velocity into time value will become like this, 2 into h by g. What is h? H is this height. This height is h. Now I calculate. G value is 10 into 2 into h. What is this height? This is 10, this is 5. So coincidentally 10 minus 5, the value of h also comes 5. It may come different in different cases. I'll take care of the h value and write here 5 and g value is 10. So 10 will go. It's coming 10 into 1. The answer is coming 10 meters. So it will hit the ground at a distance of 10 meters from the bottom of the tank. The value of r will be this much. Okay, a similar type of question we have in the book. Question number 8 is multiple choice type. Question number 8 of page 409. Question number 8 of page 409. I draw the diagram for this question. Question says there is water out there. The total height of the container is given h, and the water is going like this. This is given small h. I read question now. Question says a tank is filled with water to a height h. Total height is h. A hole is punched in one of the balls at a depth h, one hole is punched at a depth h from the water level, water surface as shown in the figure. The distance from the base of the tank where the resulting stream strikes the floor is given by, you have to find this distance, and that distance must match with one of these answers given in the choices. So I think the thing is same. First we find the velocity here. So what is the formula of velocity? Velocity formula will become root 2 g this h at h. Mark this equation. Now this range we have to find range. This is horizontal distance. Horizontal distance formula here velocity to tank, but the tank formula will be like this 2. But this height from this is the height from which it is falling down. This height value will come h minus h. So here we write here h minus h upon g. I put the value of v. R is equal to root 2 g h into twice of h minus h by g. Cancel, g and g will cancel. Root 2 into root 2, 2 will come out, and this root thing will multiply again answer h, capital H minus h. So this is the correct answer. Now will be matching. I think this is matching with the option B according to the question. The option B is the correct option. Okay. This is one question, and then another question is question number 9 of the same page. This is also important one, important type. Question number 9. Page number 409. 409. So I read question. Question says a water tank resting on the floor has two orifices, orifices. Orifices means holes, A and B, capital A and B, vertically one above the other, vertically one above the other. Now question says the orifices are at heights. The orifices are at heights h1 and h2. H1 and H2. H1 and H2 right under bracket less than H1, less than H1. That means H2 is less than H1. As measured from the floor. As measured from the floor. Full stop. If the jets emerging out, from these orifices, hit the floor at the same point, comma, then find the height of the water in the tank. Okay. So diagram not given, we draw ourselves. There is a tank. Maybe water is still here. There are two holes A and B. B hole is closer to the ground because H2, this is A, this is B given. The orifices are at heights H1 and H2 measured from the floor. This is the height of A. Height of A is H1 given. Height of this is H1. And height of B is H2. This is given H2. And then let us suppose the total height is H of the. We have to find the value of H. Height of the water level above the ground level is H. This H only we have to find. And the clue given is from here and here, water is striking the floor at the same point. What should be the value of height of the water level above the ground? That only we have to find. What is the height of the water in the tank? Okay, first we will be finding the value of, this R value will be same for both. So you can find the velocity at this point and velocity at this point. Or we can do it directly, that velocity at A, the formula will be root 2g height, this height. What is this height? The total is h, this is h1, so I write h minus h1. Therefore range for A will be velocity into time formula here, that is 2 into this height, this is h1 by g. Putting the value of v, the value of v comes this much, root of 2g h minus h1 into 2h1 by g, cancel, g and g cancel, 2 comes out. Here we have the circle g h minus h1 and h1. This is the value r. Mark this in equation number 1. Similarly, we will be finding the velocity at B. Same way, velocity at B. That will be v is equal to again 2g. What is the height of this hole from this surface? That will become h minus h2. Therefore, range for this will also come the same. Velocity is this much, 2g h minus h2 into time will be 2 this height, that is h2 by g and g cancel, so the get answer coming is 2 h minus h2 into h2. Equation number 2. These two ranges are equal. Therefore, from equation 1 and 2, from equation 1 and equation 2 will make them equal. 2 cancels here. 2 will come out. 2 cancel, make them equal. You can add this twice of this g h minus h1 into h1 is equal to twice g bracket h minus h2 into h2. 2 cancel, g will also cancel, squaring both the sides. Now you have the answer coming as h minus h1 into h1 is equal to this side, h minus h2 into h2. Open bracket, you get h1 minus h1 square, h2 minus h2 square. Keeping h's together, h1 minus h2 is equal to, this will go that side, h1 square minus h2 square, h common, it becomes h1 minus h2 here, and write h1 plus h2. These two cancels. Therefore, h value will be h1 plus h2. This is answer. So, according to this question, the option C, it is matching with option C. Option C. Then is what should be the height of the tank? The height of the tank must be equal to this value, h1 plus h2 value. That is the answer. Now after this we have some questions where you have to find terminal velocity and all. It is given in the book. You can try it out yourself and find the answer. Direct formula based. So I just take the question number 9. Problem 9 of page number 412. Page number 412. Question number 9. Page number 412. Question number 9. Find the terminal velocity of a raindrop. The terminal velocity of raindrop is 30 centimeter per second. The terminal velocity of raindrop is 30 centimeter per second. Taking the viscosity of air, as 1.8 into 10 to the power minus 5 pm, Poisson, pm, capital P, small m. Full stop. What is the radius of the raindrop? Okay. V formula goes on like this: 2 by 9 R square D minus rho into G by eta comes down. We have to find the value of R. Terminal velocity is already given in the question. 30 centimeter per second, which is in meter, that is 0.30. 2 by 9 as it is R square we have to find. D stands for density of the drop. This drop is red drop. Then we have to take the density of water. The density of water value is 1000. And rho is the density of the medium in which it is falling. So it is falling through the air. The density of air not mentioned in the question, that means it is taken as 0. You can neglect it. And the value G you can take 10. And eta value is already given in the question. 1.8 into 10 to the power minus 5. This coefficient of viscosity value given. Using this, we will find the value of R, and the value of R will come out to be. It will come 5 into 10 to the power minus 5 meters. This answer is fine. If you change in millimeter, then millimeter is 10 to minus 3, the answer will come 0.05. Answer. This was the solution for number 9. So direct formula based question you have here on the same tag. Question number 7, 8 and 10. 7, 8, 10 you can try at home. If you don't get it, you can ask me, then I will do it. Okay, thank you. This much is there in this chapter. Next day I will start new chapter, surface tension.